Determinant of a matrix. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. Every square matrix has a number associated with it called a determinant, and this number is used in calculating the inverse of that matrix. The determinants are defined only for a square matrix. It is denoted by that of A or A between two bars for a square matrix A. Determinant of a 2 by 2 matrix. If a 2 by 2 matrix A is given by, the determinant is given by, the determinant of a matrix 2 by 2 is the product of the elements on the main diagonal minus the product of the elements on the other diagonal. Let's see how it works. Evaluate the determinants of the following matrices. Find the product of the elements on the main diagonal. And subtract the product of the elements on the other diagonal. Find the product of the elements on the main diagonal and subtract the product of the elements on the other diagonal. Before explaining how to find the determinant of a 3 by 3 matrix, you need to learn what a cofactor is. Cofactor. A cofactor is a number associated with each element of a matrix. A cofactor associated to an element Aij is given by. Let's see how it works. Given the matrix A, find the cofactors of the following elements. A13, A32. To find the cofactor of the element A13, take the formula, replace I with 1 and J with 3. Mij is called the minor determinant. The minor determinant corresponding to each element is the determinant of the 2 by 2 matrix, formed by deleting the row and column containing that element. The minor of the element A13 is the determinant obtained by deleting the row 1 and column 3. Minus 1 raised to the power of 4 is equal to 1, and the minor determinant is equal to minus 86. The cofactor of A13 is minus 86. To find the cofactor of the element A32, take the formula, replace Y with 3 and J with 2. The minor of the element A32 is the determinant obtained by deleting the row 3 and column 2. Minus 1 raised to the power of 5 is equal to minus 1, and the minor determinant is equal to 42. The cofactor of A32 is minus 42. Determinant of a 3 by 3 matrix. To evaluate the determinant of a 3 by 3 matrix, we choose any row or column of the matrix. This will contain 3 elements. We then find 3 products by multiplying each element in the row or column we have chosen by its cofactor. Finally, we sum these three products to find the value of the determinant. Let's see how it works. Evaluate the determinants of the following matrices. To find the determinant of the matrix A, follow the steps. Step 1. We can choose any row or column in the matrix. A special property of determinants is that it does not matter which row or column we choose, as we will always get the same value regardless. In practice, it's usually a good idea to choose a row or column containing as many zeros as possible, because any value multiplied by 0 is 0. In matrix A, we have no 0, so we pick the first row. Step 2. Multiply each element in the row or column we have chosen by its cofactor. Find the minor determinants. Minor 1, 1, minor 1, 2, minor 1, 3, Step 4. Sum these three products to get the determinant. To find the determinant of matrix B, we follow the same steps. Step 1. We can choose any row or column in the matrix. We should remember that if any of the elements in the row or column that we choose are 0, then we don't need to find their cofactors, since the cofactor will be multiplied by 0, and any value multiplied by 0 is 0. Matrix B has an element that is 0, so it's a good idea to choose the third column or the second row. We pick the third column. Step 2. Multiply each element in the row or column we have chosen by its cofactor. Find the minor determinants. Minor 1, 3. Minor 2, 3. We don't need to find the minor 3, 3. Step 4. Sum these three products to get the determinant.